Hello everyone, my name is Nargis Ahmedova, and now I'm going to present my project MedIm, artificial intelligence system for pneumonia detection. The project's aim is to automate detection of lung diseases, especially pneumonia, based on radiology images, X-ray images, as you can see on the picture. Why this project is important? Currently, we have COVID-19 pandemic, which is rapidly expanding all around the world. So fast diagnosis will accelerate the treatment and increase chances of patients to recovery. And the one thing in which artificial intelligence highly prevail human is lack of human factor error when we use the computer vision, computer thinking in analyzing data and evaluating the result. What is research based on? It is based on neural networks, a set of algorithms that represent the human brain operation in the technological form. It's endeavors to recognize underlying relationships in the set of data. Here we have a chart which represents the distinction between traditional programming and machine learning. First chart shows us that in traditional form of programming, we give the exact rules, like we write an algorithm, and we give for this algorithm inputting data, and we get some desired answer. However, when we talk about machine learning, we first give the resulting data and inputting data. And based on a set of correlations between results and inputs, we can evaluate the algorithm itself for the future use. Actually, we came to describing my project. I use the open source publicly Kaggle. There I found the set of 2,400 images, X-ray images of lungs of humans, which are classified to ill, which is 1.0 in the class, or 0.0, which means this human is healthy. And there's also division for training and testing data. Training is aimed to provide the learning information, and testing is to just check if the model evaluates the answer correctly. Here we're just getting data, get metadata, and representing data, just output. Actually, we came to the point where I'm going to discuss how I evaluated the most efficient model. Here we have on the slide 4 distinct models. Machine learning, first is a key near neighbors classifier. The second in the right corner is a logistic regression example. Under that, we have a decision tree, and in the left corner, we have a convolutional neural network. And I based on the accuracy score that those models provide based on my data set. And we can, how to say, why? Here we just representing the final output, which is a CNN classifier. We show that first it fits like a function that uses train data to learn, and epochs is a number of full cycle of learnings. There you can see in the next picture, and with each of the epoch, the model is increased its accuracy and decreases the loss of the function. Higher, bigger number of epochs, consequently, higher efficiency. So why I didn't use the decision tree, key near neighbors, or logistic regression? Here's the answer. Because key near neighbors give me score of 0.7, which is a 70%. Logistic regression and decision tree score even less, but convolutional neural networks give me score of 93%, which is why it is the best model to use in analyzing the X-ray images. So we use the function of predict by the test data and evaluate the accuracy score. Here, how those doctors can easily use this application in diagnosis, because they are not acquainted with those functions, and for them it will be very difficult to implement if they have to write some code, which is why I developed the user application. It is kind of primitive in design, but it should be simple. Instructions in this pressing this button will give a short outline of all directions that doctors should use. It will not be a big number, but there will be some hints. And when it presses start, it like shows him another window where he can press upload image, and it will just appear in this box. So when he press evaluate, it just writes a status, positive or negative. Exploitation. The exploitation reason for this model is increased quality of diagnosis, because 94% is a very high number. So AI concepts incubations implementations, it is a more technologically oriented goal, because currently we are like in one step of becoming fully robotized, and this will give the high opportunity to automate even the process which like 20 or 30 years ago I would say will be impossible to automate. So why, how can we automate the thing? First, we use a Firebase. It is like a all cloud database where we can store images that radiology have in their like computers. So then we have a desktop application which I developed, and artificial intelligence code which is put into this desktop application for future use. This is all with the presentation. Now I'm gonna show you the working process of my model and working process of my application. Here we can see the same. Yes, ill class ill1 is ill, healthy is 0. This is a chart that represents how I wrote this code. Here I define the classifiers and objects, key near neighbors, logistic regression, and decision tree. After that, I put the all fits using the training data and testing data. This is a def score. It is a function additional that I didn't use, but here I use the score of CNN to just like an example. Here, after that, I use the same function for logistic and decision tree classifier. Here, it is the final evaluation of a model, and it uses the CNN classifier from TensorFlow and Keras. It is also open source library, which provides opportunity to make these machine learning models. And here we have all the code. we can just look how the model becomes more and more accurate by the time it comes. And this is the 94%. Yeah, and this is a chart. It's data visualization of validation and training data. Now we can move on to this, to the project. I wrote it on Visual Studio using C#. So now we're gonna see how this application operates. Press button start. We press button upload images. We can find the picture of lung. Evaluate, positive. The model evaluated that the status of this image positive. And it will do the same thing when the doctor would need that. So that was the end of my presentation. I hope that you enjoyed and find my presentation is useful. Thank you.